This conference will now be recorded.
Good afternoon, dear members and industry colleagues. A hearty welcome to all of you to today's web seminar on revolutionary innovative solutions for highly challenging fluid dispensing applications organized by the German Engineering Federation VDMA in association with Viscotec. We hope all of you and your family and colleagues are safe and doing well. I'm Jamli John, based out of the Mumbai office of VDMA, and I'll be taking you through the session. Before we continue, we'll request all of you to kindly keep your microphones muted and cameras switched off at all times. You could continue to post your questions to us under the chat box, and we'll be taking it up in the last leg of the web seminar in the Q&A. The next slide. VDMA, the Mechanical Engineering Industry Association, was founded in November 1892 and is the most important voice for the mechanical engineering industry. VDMA represents around 3,348 members, mostly medium-sized, making it the largest industry association in Europe. The members who currently contribute to 78% as exports, which is equivalent to 205 billion euro production. Recognizing the very early significance of India as a future market for our member companies, India was one of the first overseas offices among the BRIC countries. VDMA is the only German industrial association having well-established network in India with their offices located in Noida, Kolkata, Mumbai, and Bangalore. Next slide. For today's web seminar, we will have the welcome address from Mr. Rajesh Nath, Managing Director of VDMA India, and this will be followed by the presentation from Viscotec Pumpen-U Dosiertechnik GmbH team by Mr. Wolfgang Merklein, the International Sales Manager, and Mr. Johannes Leah, the Business Development Manager. We would then conclude with a Q&A session. Next slide. Mr. Nath has been having 3 decades of experience across various industries both in Germany and India, and has been the face of VDMA for more than 2 decades. He's also been accorded the Cross of the Order of Merit, which is the highest civilian order from the German President for promoting Indo-German trade in the engineering sector. With no further delay, I'd like to hand it over to you, Mr. Nath.
Yeah, thank you, Jamli. Good afternoon, members and all friends from the industry. Hearty welcome to all of you today at this web seminar on revolutionary innovative solutions for highly challenging fluid dispensing applications being organized by the German Engineering Federation, VDMA, in association with our partners today, Viscotec. I extend a warm welcome also to Mr. Wolfgang Merklein, International Sales Manager, Viscotec Pumpen-U Dosiertechnik GmbH, Mr. Johannes Leah, Business Development Manager, Viscotec Pumpen-U Dosiertechnik GmbH, Germany. Friends, in India, the Production-Linked Incentive or PLI schemes was launched to establish global manufacturing champions across 13 sectors with an allocation of about 1.97 lakh crores or US $27 billion over the next 5 years, starting financial year 21-22. The scheme has generated interest among global investors. For example, on February 16, 2021, Amazon India announced to start manufacturing electronic products in India, starting first with the Amazon Fire TV stick. The company plans to start manufacturing with contract manufacturer Cloud Network Technology, a subsidiary of Foxconn in Chennai by end of 21. In April 2021, Bharti Enterprises Limited and Dixon Technologies formed a joint venture to take advantage of the government's PLI scheme for manufacturing of telecom and networking products. In India, the market for grain-oriented electrical steel sheet manufacturing is witnessing high demand from power transformer producers due to the rising demand for electrical power and increasing adoption of renewable energy in the country. In line with this, in May 2021, JFE Steel Corporation, in collaboration with JSW Steel Limited, signed an MOU to evaluate a study to establish a grain-oriented electrical steel sheet manufacturing and sales joint venture company in India. In May 2021, as per IT Secretary of Ministry of Electronic and Information Technology, the government plans to introduce an incentive scheme for 3 to 4 large investments in the next 6 months to establish fabless display manufacturing units in India. India's display panel market is estimated to grow from $7 billion in 2021 to $15 billion in 2025. The appliance and consumer electronics ACE market in India is expected to grow to $21.18 billion by 2025 from $10.93 billion in 2019. In April 2021, the Union Cabinet approved a PLI scheme for white goods, ACs and LEDs worth 6,238 crores rupees or $840 or approximately 841 million to boost the manufacturing industry. Friends, the electronic and information and communication technology are transforming the idea of mobility. The market for auto electronics is estimated to exceed $200 billion by 2021-22. The use of electronics in automobiles is the largest driver of change in this sector. Nearly all automotive innovation arises directly or indirectly from development in electronics. Most of the solutions designed to lower emissions, improve fuel efficiency, increase safety, and provide convenient services like infotainment for customers are dependent on electronics and associated embedded applications. Currently, more than 75% of all electronics used in cars are imported. Concerted efforts from both the government and the industry are required to propel the Indian auto industry into one of the critical GDP contributors in the near future. Hence, through production-linked incentive scheme, the government is keen to make India a manufacturing hub and increase our exports, and through that, our contribution in the global value chain. Friends, the aim of today's web seminar with our partner Viscotec is to provide insights on challenges faced currently in dispensing processes. The speakers will highlight case studies from some of the sectors I mentioned earlier, like electronics, e-mobility, automotive, as well as aerospace. Reliable, precise, and accurate dispensing will certainly help to increase productivity and enhance the quality of the products. Hence, we look forward to informative presentation from Wolfgang and Johannes. Before I hand over to my colleague 𝐸𝐿𝐴 to introduce our speakers, I would like to conclude with a quote from Paul Meyer, who is considered by many to be the founder of self-improvement industry. Paul Meyer said, "Productivity is never an accident. It is always the result of a commitment to excellence, intelligent planning, and focused efforts." So thank you, friends, for joining us today for this important web seminar. And I hand it over now to 𝐸𝐿𝐴. Thank you.
Thank you, Mr. Nath, for just setting the right tone, I think, for the web seminar and getting us all up for this. We are pleased to welcome our speakers for today. Our first speaker, Mr. Wolfgang Merklein, the International Sales Manager from Viscotec. He has been very active in the Asian market and has been associated with Viscotec for the past 13 years. He's engaged in the fluid dispensing area since the very beginning of his career. And his areas of expertise are the automotive, electronics, general industry, and the food and cosmetics sector. Our second speaker for today is Mr. Johannes Leah, who is the Business Development Manager with Viscotec. Mr. Leah has been working with Viscotec since 2018, and his area of expertise include e-mobility and the aerospace industry. Thank you, Mr. Merklein and Mr. Leah, for joining us, and we eagerly await to hear and learn from you today.
Thank you very much, Mr. Nath and Mr. 𝐸𝐿𝐴. So I think, yeah, we can start with our seminar now, or our presentation. So as mentioned, the topic for today is to give you an insight in revolutionary innovative solutions for highly challenging fluid dispensing applications. So next slide. Okay, first of all, I'll give you a short introduction of what we are planning to inform you or to present you today. First of all, I'll give you some current trends information. Then I will give you an insight into challenges faced in fluid dispensing applications. Then a short or brief introduction of Viscotec company profile. And then Viscotec solution and success stories. Then I will pass over to my colleague, Mr. Johannes Leah, who gives you an insight into e-mobility challenges and aerospace challenges and practical case studies. Last but not least, we will give you a short outlook for the topic for the next seminary, planned seminary for our Preflow brand and with the micro applications. Next slide, please. Okay, so I'll start with some current trends. Mr. Rajnash already mentioned some current innovation trends. What is being driving the innovation now? So in the mobility sector, main important topics are for automotive or aerospace in general. Autonomous driving, the cars are connected. You have all the electromobility applications. New planes are planned with new aerospace concept in general. In the communication area, you will develop, or next generation smartphones will be developed with a total or global connection and with linked devices everywhere. In the energy and environment sector, renewable energies are very important. Climate neutral products, of course, and hydrogen technology, which is a very innovative technology, is to be developed. So there is an increased requirement for all these products in these areas. The lifetime of the products and availability should be increased. Of course, the quality level should be increased as well, and we should have highest quality standards. Energy saving and reduction of the carbon footprint is a very, very important topic globally. Also, the easy to access for the products and reliable products in general. Next slide, please. What does this mean for manufacturing? So there are demanding requirements, and the production processes and raw materials are adapted to these new products or required products. New materials are used, so latest R&D developments in case of any raw material or production materials. This leads to challenging processes and products in manufacturing. So these challenges have to be adapted in your factory or during production. The efficiency has to be increased and also the flexibility. Downtimes has to be decreased and the yield has to be increased, as well as the quality and output range. Introduce state-of-the-art material, products and processes has to be introduced. Next slide. When I come more detailed to the fluid dispensing manufacturing processes now, these are tremendously increasing in all production processes. So the adhesive bonding process is replacing traditional methods like welding, rivet or screw connections. Higher flexibility is possible by using adhesives, and also new products are possible by using new developed materials. The performance, features and quality, as well as product life, reliability and new features are increasing as well. The dispensing process should be repeatable and very process safe to have a really an alternative for the traditional methods like the welding or screw connection. In this area, there's a next technology step for fluid dispensing. So far up to now, when it came to fluid dispensing, very often very simple solutions were used, which were also simple technology, and the results were not so good, but it was not that important. Nowadays, with the new developed adhesives and also with the increasing costs for these adhesives, a very high precise dispensing solution is needed and really necessary. Also, we have very new developed or latest developed adhesives, special glues, which are highly sophisticated chemical structure and properties. At the bottom, it's just an example I give you here for the adhesive content in an average car nowadays. So you have 15 to 18 kg adhesives per car average. You have 50 to 150 meter of bonding beads or lines per car. And 70% of all connections in a car are glued nowadays already, which means 9% of the global adhesive production worldwide are used for the automotive sector. Next slide, please. Okay, so this leads to challenges during the dispensing processes as well. Factors which are influencing the dispensing process are, of course, the type of the adhesives used, the choice of the correct dispensing systems, and very often dispensing systems are also integrated with robots and automation. Of course, the conveying and handling of material is also a very important topic to consider. Next slide, please. What do you need to keep in mind when you deal with adhesives? So you have to consider that is a chemistry or some liquid. So you have to consider the rheology of the liquid, the typical features like reaction time, curing times, but also some topics like high flammable risks or also abrasive particles and thixotropic. A faulty design or choice of a dispensing system leads often to production delays, quality rejections, and of course increased scrap, waste, and losses. Typical errors are that it's not really defined which parameters are needed for the dispensing, so layout is not taken seriously, and wrong consideration of hoses or the equipment leads to these typical errors. Next slide, please. How is an effective dispensing system designed? So it's first of all very important to look at the handling of the material. Are there any requirements for circulation, agitation, degassing, or also some pre-treatment of the material? Next step would be the choice of the dispensing technology. There are many different dispensing technologies available, from simple one really to highly sophisticated ones. So you have to consider the required accuracy, precision, and also other requirements like flow rate, dispensing type, and also the pressure situation within the system. Next slide, please. I mentioned already that there are also challenges with newly developed materials and adhesives. So nowadays, really high viscosity pastes and liquids are available, as well as phase-changing material. This phase-changing material is a mixture of a liquid and a solid material, which change its phase by a certain temperature. Also for the thermal management applications, highly filled materials are needed or developed, but my colleague Johannes will explain more details later on these materials. Combined contouring materials are also very highly sophisticated materials. So for example, you have multiple curing methods like UV or heat curing. And of course, chemically aggressive liquids are also included in adhesives, which needs to be considered. Next slide, please. Okay, as mentioned, I give you also a brief introduction of Viscotec, and we start with a video where we can give you some insights into Viscotec. As you can see here, we're starting from a satellite. Viscotec develops really highly sophisticated solutions for satellites, cars, mobile phones, and all kinds of electronics. You can see here a typical application for the electronics display bonding application with a typical Viscotec dispenser. This system, a simple dispensing system of Viscotec, looks like this. You have a cartridge feeding, a dispenser, and the connection by an electric motor. Gentle handling is guaranteed. The material feeding is done in this case by the cartridge, which will be fed into the dispenser itself. So you have a continuous flow rate, and we are using the technology of the endless piston, which means rotor stator, and this is providing the exact dosing amount of the application. Okay, here you can see a typical application mounted on a robot, so doing some sealing beads on a housing electrical part of automotive. Next example here is for photovoltaic application. Okay, then I come to Viscotec in general. As mentioned, well, as you know already, we are a German-based company with our headquarters based close to Munich. So all the production is done in Germany. We have subsidiaries worldwide to provide service technically and sales assistance in India, China, Singapore, France, and US. Next slide, please. When it comes to fluid dispensing, independently if it's an adhesive or another liquid, our systems could be used. So, for example, for renewable energies, pharmaceuticals, aerospace, cosmetics, electronics, 3D printing, food, automotive, or general. Next slide. As mentioned, we are handling very different materials. In the adhesive sector, we have adhesives like 1 and 2 component adhesives, UV curing, RTV silicons, epoxy, PUs, silicons, many different types. Next slide. What is important here? Our brand values. So as mentioned, Viscotec stands for precision. Highest precision is really our aspiration and that of our customers. We are providing reliable products, which stands for process layer reliability. The technology we are using is the endless piston technology, and this is a basis for our high quality products. This leads in the end to high quality products, and this quality of our product is reflected in the results that impress with their precision. All products I mentioned already are made in Germany. Next slide, please. Okay, to introduce or give you an introduction of the technology we're using and showing you the endless piston principle. On the right, you can see again the rotor, which is a stainless steel screw moving in the stator. This stator is made of some rubber, so it looks like an auger valve, but this system is a completely tight and sealed system with a rubber part of the stator. This technology allows to have a defined output per 1 revolution of this dispenser. It's driven by a servo motor electrically and very easy to operate. So by controlling the speed of this stator and rotor, you have a defined output, and then therefore you can adjust the flow rate, the required one. This technology allows pulsation-free dosing, can handle very high viscous liquids up to 7 million CPS, is a valveless technology because this complete system is tight and offers a 99% repeat accuracy. This system can be also used backwards. So by turning the screw in the other direction, we can have a suckback function. So we have no dripping, and it's a very clean and precise system. Next slide, please. Okay, here's just an overview. With the blue column at the top, you can see which viscosity areas can be handled by Viscotec systems and technology. So it's more or less from water up to this very high and several million CPS liquids, whereas the other technologies are really limited to a special viscosity range. Next slide, please. Okay, next topic are Viscotec Solutions. We are in general offering modular systems. So we have some system groups of emptying systems, preparation and treatment, and dosing systems. And we develop these systems according to really your requirements. Next slide. Okay, here's an overview of typical dosing systems for 1 and 2 component applications. Next slide. The group of emptying systems we can offer here is for starting from small bins, from cartridges up to very high content barrels up to 1000 liter or typically the 200 liter pails. Next slide, please. And I mentioned we have treatment systems, so special systems for materials which need treatment like degassing or also circulation or agitation. Next slide, please. This is a typical layout of a 1-component dosing system. On the left, you can see this Visco MTXS. It's a pail emptying system for feeding. We have a hose connection, a pressure sensor, and the typical RD dispenser, which is using our endless piston technology. Next slide. We have the same for 2-component dosing applications. So you can see again, here's some emptying system for component A and B, left and right. A treatment system for the gassing is needed here. And also we have 2 dispensing heads for the 2-component head. The big advantage is that we have the mixed material for these 2-component parts only in the static mixer, which is a consumable. So we have no mixed material in the part, which allows really no cleaning or additional efforts. Next slide, please. Okay, now I present you some challenging applications or solutions we had so far. Next slide. In general, when we have liquid dispensing projects and when we develop a solution for your needs and your requirements, we are working together with you as the end customer normally. The end customer defines specific requirements and expects a perfect solution. Then, at the beginning, also the material manufacturer of the adhesive came into the field because they have all the details with the specific liquids, and he's the specialist on this. The next party will be the integrated automation company. They will do the complete integration with robotics, handling, and also integrate the dispensing equipment. This is the last party, like Viscotec, the dosing equipment manufacturer. They are, or we are, the specialists for really the dosing application itself. So at the end, all these four parties define and develop the perfect solution to provide the best solution for this application. Next slide, please. To give you some examples of difficult projects or challenging applications we had, this is an example of an air curing dry lubricant. This is a very special material, and this is for some throttle valves, as you can see here on the top. This lubricant is containing solvents and non-mixable particles like graphite. So it's very, very difficult to handle this material because it has an extreme sedimation effect. So we have to keep this material always in a circulation loop to avoid this settling effect, and those that the dispensing is blocked. We have considered here a special dispenser with circulation, a feeding pump here, and a tank where the material is fed at the beginning. And it's always kept into the circulation. Next slide, please. Here you can see again the system, and it was completely customized and engineered solution. And of course, it was necessary to do some tests in advance to confirm the feasibility and the process and materials. Next slide, please. This example of a challenging application was optical bonding. As mentioned, our systems are very often used for display bonding applications. So worldwide, there is an increasing demand of smartphone, computers, and touch screens in general. Next slide, please. To manufacture this display bonding, we have typically two emptying or preparation systems like the degassing. As you can imagine, it is a translucent two-component silicon. So it's very, very critical to have any air bubbles here. So all air bubbles have to be removed by our degassing units for component A and B. Of course, highest requirements were needed for accuracy and mixing ratio, and it's a fully automated solution with one of our two-component systems. Next slide, please. Okay, this example is all again a one-component system, but it was completely heated. As you can see, it's used or fed by a pail again, but then we used some heated hoses with some heated pressure sensor and heated dispenser. All this heating is done electrically because we had to handle this heated material. Next slide, please. This is again a heated system or a temperature control unit. As you can see, you have a complete housing or a dispensing box where our systems were integrated. So it's material that needs to be kept chilled at 23 degrees centigrade, and also they need to be degassed to avoid air bubbles. So we were considering a complete climate chamber, pail emptying, degassing, and a two-component mixing head of Viscotec. Next slide, please. Yes, here you can see again the inside again. You have the pail emptying system, the degassing system, and the mixing head. Next slide, please. This is some Viscotec laboratory slide. I mentioned we are doing some tests with our systems in the laboratory, normally before each project starts, for new processes together with you as a customer and for new materials. Next slide, please. And here's the Viscotec Customer Innovation Center. It's a new building we have with several laboratories to perform these tests in advance and to define and confirm the feasibility of the application. Now I come to the next slide and I hand over to my colleague Johannes, who will give you an insight for special applications, e-mobility and aerospace.
Yeah, thank you very much, Wolfgang, for the nice introduction of the first part of the presentation. Now I would like to continue, as mentioned, with the business development units, e-mobility and aerospace. And yeah, as mentioned before, today's focus is on typical dispensing applications with very, very challenging material properties. So next slide, please. First of all, before I start, let's have a quick look on the agenda. So I will start in general with an application overview of each business development unit. Then I'm going to provide a theoretical background on specific dispensing application and its industrial challenges. So just to give you a better impression of the requirements at all. And then finally, I will present different Viscotec solutions depending on the application itself. Next slide, please. Okay, let's start with business development e-mobility. Next slide, please. Here you can see an overview about our typical dispensing applications in the e-mobility industry. You can basically divide these applications into two areas. So on the one hand side, there are applications within the e-drive production, like resin impregnation or magnet bonding. And on the other side, there are applications within the cell and battery production, like sealing, so top cover sealing, for instance, of battery housings, slurry dispensing, thermal management, and battery pack assembly. So today's focus is on two applications. It is on resin impregnation and thermal management. So next slide, please. I'm going to start with thermal management. So the overall topic is dispensing of thermal interface materials, so-called TIMs, and gap filler on battery modules. Next slide, please. So I will start with a theoretical background. So why is thermal management of HV batteries so important? And there is a very simple answer: because HV batteries work best when kept in a specific temperature range. So theoretical values are within 15 to 35 degrees of Celsius. But what does it mean, work best? That means the ability to manage heat during charge and discharge cycles is crucial for a high battery performance. And furthermore, it is very important to keep the core components of electric vehicles at temperatures that facilitates maximum charging efficiency, durability, and maximum driving range. And finally, most important, because of safety reasons, we need to ensure a safe operation, which means to avoid overheating of the battery system and finally to protect the passengers. Next slide, please. So now, to get the best performance out of HV batteries, that dispensing and applying of thermal interface materials is an essential task in battery manufacturing and an important key element within the battery cooling chain. So to keep the production rates at a high level, high flow rates are a typical process requirement, but also furthermore, besides a complete material distribution, a continuous dispensing process and different dispense patterns are needed. As you can see on the illustration on the right-hand side, there's a typical bead dispensing process. Next slide, please. But now, what are the industrial challenges when it comes to dispensing of thermal interface materials? So for an optimum thermal management, a complete and air bubble-free material distribution is needed. So air bubble-free is the word here. As illustrated below, as soon as the gap filler contains air inclusions, the thermal conductivity gets negatively affected. A look at the thermal conductivity properties of air compared to a standard gap filler shows the huge difference. So the thermal conductivity of a gap filler is at least 100 times better, and any air entrapment acts like a kind of isolator in this process. So next slide, please. So what are further process requirements or challenges? Abrasive filler characteristics and highly viscous materials. So thermal interface materials are highly filled to achieve a maximum thermal conductivity. That's the goal, definitely. But usually ceramic particles, for instance, made of aluminum oxide, are therefore used. And a high filling level not only enables an excellent thermal conductivity, it also leads to a high abrasiveness abrasiveness, which can wear out the dispensing equipment quickly, as you can see in the illustrations below. And furthermore, as can be seen on the chart on the right side, as soon as the gap filler, the ceramic particles are increased, the overall viscosity is increased as well, which slows down the manufacturing process and finally contradicts a cost-efficient and fast production. The next slide, please. I would like to present you our Viscotec solution for all these challenges and for this application type. So next slide, please. And please start the video. So this is a two-component dispensing system for gap fill applications in the e-mobility industry. Sorry, can you go one step back because we skipped the video right now? Only one click should be fine, somewhere at the picture. Yeah, leave it as it is right now, so it continues by its own. So always depending on the material consumption, but typically for the base component, a 200-liter barrel emptying system is used, as you can see here. It is connected to a material preparation system and degassing system, including agitators to avoid sedimentation and eliminate air inclusions. Optionally, it can be fully heated and it can be circulated as well to avoid any sedimentation within the pipes. On the other side, for the hardener component, we can use a barrel pump emptying system connected to a viscotreat system, also a preparation system, to buffer the material and to avoid any sedimentations for the hardener component as well. So usually both preparation systems are then connected to the two-component dispensing system itself. And as can be seen, we react to different mixing ratios with different pump sizes, and also in this case only component A has to be heated to reduce the viscosity to enable a better mixing quality in the end. So the final result is a complete material distribution under the battery modules to enable a perfect thermal conductivity of the heat, so a perfect heat dissipation from A to B. This system, which you can see here, is a highly customized solution, but this system is also used at different OEMs worldwide. Another feature here is the ceramic rotor technology. As mentioned before, this kind of materials are highly abrasive, and compared to our standard rotor, which is out of stainless steel, we can implement a ceramic rotor to significantly increase the service life of our equipment. Okay, so next slide, please. Now I would like to continue with the second application, resin impregnation. So for a better understanding, here you can see a complete production process of electric motors. When it comes to stator and rotor production, Viscotec is typically used for resin impregnation and magnet bonding. As said, I would like to put a deeper focus on resin impregnation today. So next slide, please. So what is resin impregnation and why is it necessarily needed? As you know, electric motors, especially in vehicles, must meet extreme demands. So there are environmental influences and mechanical impacts. So they must be able to withstand rough environmental influences like moisture or dust and mechanical impacts such as shocks and vibrations. Also, in the case of high electrical stress, the motor is exposed to high temperatures as well. So to avoid such kind of failures, the stator or the rotor windings are impregnated with resin, and this is also an application for Viscotec. So next slide, please. One more slide, please. Yeah, back to the industrial challenges, right? So what are the industrial challenges for a typical dispensing process? The basic process required is an accurate and maximum filling of winding slots, as can be seen on the picture on the right-hand side. Therefore, it is not allowed to introduce any air during dispensing, as well as a safe material handling, which means no dripping at the end of the dispensing process needs to be guaranteed. But let's have a quick look on the Viscotec solution. So next slides, please. Okay, so I will continue with the Viscotec solution. Right, so here you can see a material preparation system, which is called Viscotec R series. So this is a typical buffer system, which can steer the material to avoid any sedimentation in between. Also, this material supply unit is especially made for low viscous resins in this case. And also furthermore, the system can be heated and the temperature can be kept due to an insulating jacket. Also, in case of longer downtimes or filled resins, the materials can be kept homogeneous and can be circulated as well. This system then is connected to a one-component dispensing system or pump. So next slide, please. So for the standard dispensing process, a standard one-component dispensing system is used. At the material inlet, which you can see at the top of the graphic, the material preparation system supplies the material. A complete system is monitored by pressure sensors, and which is different to standard dispensing systems, there's a small or a short hose between the dosing needle and the outlet of the dispensing pump. This is needed to position the needle at the exactly point where it is needed at the coils in the end. But I would say let's have a quick look on a brief video to give you a better impression of the dispensing process as well. So next slide, please, and can you please start the video with one click? Right, so this is this was a test done in our laboratory, resin impregnation of rotor and stator, trickling with Viscotec dispensing systems. So this is a typical setup as described before. This is a Viscotec R buffering and preparation system, which is then connected to a one-component dispensing system. As you can see here, this is the small hose at the end of the dispensing pump, which is then connected to the dispensing needle. The coils are rotating, and depending on the process, sometimes only one needle is needed for a dispensing process, but we can also implement several needles to increase the production rate. So this is a one-component dispensing material. The rotation is needed to get a better material distribution, and in case of one-component resins, we can achieve a faster curing time once the system or the coils are heated as well. So these are the typical benefits of Viscotec dispensing systems. So we can use one or two component impregnation resins, that doesn't matter. We can mix two components in situ, and we achieve air bubble-free dispensing process and a homogeneous material supply. And this is based on our technology, the endless piston principle. Okay, so next slide, please. Now I would like to continue with business development aerospace. Here you can see a typical overview of our dispensing applications within the aerospace industry. So today's focus is on sealing and honeycomb potting, but we're also present for inset bonding, edge filling, edge sealing, and mix on demand applications, for instance. But now I would like to continue with sealing. So next slide, please. Perfect. So sealing of fuselage structures in aircraft production. So doesn't matter, side shells, wing shells, fuel tanks, and fuselage structures are made of carbon fiber reinforced plastic, aluminum, or organic sheets and get connected during production. And therefore sealants are used, for instance, to avoid corrosion. And typically these sealants are polysulfide sealants, which have been a go-to in the aerospace industry because of their durability and low temperature resistance. So you need to imagine once the aircraft is at the airport, there are temperatures like 30 or 40 degrees at the bottom, at the ground. And once it is up in the sky, we have temperatures of minus 40, 50 degrees. So there's a huge temperature fluctuations. And now we need to ensure safe operations. And therefore the polysulfides are perfectly matched, I would say. There are both one-part moisture cure and two-part catalyst cure types available. Okay, yeah, that's fine. Next slide, please. So what are the industrial challenges when it comes to sealing of fuselage structures? Traditionally, aerospace sealants have been provided in two-part tech kits or SEM kits, what you can see on the right illustration, which are just mixed before usage. A further option is the usage of pre-mixed and frozen so-called PMF cartridges. Modern formulations are also quite lightweight, allowing them to contribute to overall weight reduction, which is also very important in aerospace industry. And the lightweight is based on polymeric hollow microspheres, which causes the compressibility of the material, and this is a huge industrial challenge. Also, the extreme mixing ratios. Furthermore, the application itself is quite complex sometimes, so therefore is individual nozzle design needed. So next slide, please. Now I would like to put a deeper focus on the compressible behavior of such polymeric microspheres. And this is, the absolutely industrial challenge. So if you have the material in the original condition, in the original container, for instance, in the cartridge, we have a certain volume of the material. But once we put pressure on the material, and even our systems are quite low pressure systems, the material gets compressed in the end. So the overall volume is reduced, and once the material exits the outlet of the static mixer, for instance, and it is on the part itself, it starts to relax again, and the volume increases again to its original condition. And this leads definitely to dripping in cartridges, for instance, and it's hard to achieve the correct mixing ratio. And based on this industrial challenge, I would like to present you our Viscotec solution. So next slides, please. So before I introduce the dispensing system itself, I would like to put a focus on static mixing technology and static dynamic mixing technology. Therefore, please start the video on the left side, right? So we give a stop signal at the dispensing process, but what you can see is the material, there's a continued material flow. So it doesn't stop, and this is exactly the behavior which I described before. The material can't be really controlled. But with our static dynamic mixing technology, if you start the video on the right-hand side, we are now able to control the, sorry, one back, yeah, on the right, perfect. We are now able to control the dispensing process. So now we give a stop signal to the pumps and to the drives. We wipe it off at the outlet, and as you can see, there's no dripping at all. And this is a huge advantage and a huge step for automated production in aircraft industry, because now we are able to control the material flow, and now we are able to avoid any material distributions on parts and surfaces where it is not needed. So next slide, please. So this is the dispensing system as described before. It is called VDMA, and this is our static dynamic mixing technology. Compared to a standard two-component dispensing system, the only difference is that there's a third drive for the mixing elements to enable the rotation. So please start the video on the right side. Here you can see or can get a better impression. So here you can see the rotating mixing elements, and the material gets conveyed and mixed until the outlet of the static mixer. And now we are able to conduct applications fully automated compared to many years ago where it was conducted manually by hand. So you don't have to mask the parts to avoid material distribution. You don't have to mix small cartridges in advance, since you're now able to use large pails or buckets. And this is able thanks to the VDMA static dynamic mixing technology. So we also have a low material waste because we don't need to mix it by hand. Okay, so next slide, please. So the final application is now honeycomb potting, so filling of hexagonal structures with potting materials in aircraft production. So again, what is honeycomb potting and why is it needed? So in order to structurally strengthen or to produce stable connection points, honeycombs, they often need to be filled during the production process. So the so-called sandwich structures are used in many areas of an aircraft, for instance, in storage compartments, in floor panels, or even in wings to reduce the total weight. Typical materials are 1- and 2-component epoxy resins, and this leads me to the industrial challenges on the next slide. So exactly what are the industrial challenges? So as said, typical materials are very high viscous, 1 or 2 component epoxy resins. Therefore, viscosities even up to 3 million millipascal seconds are quite common. Furthermore, the materials are usually filled with a high proportion of hollow glass spheres in order to reduce the final density. So usual values are between 0.5 grams per cubic centimeter or even up to 0.75. As you can imagine, and as can be seen on the photo on the right, it is definitely challenging to mix these kind of materials properly. And common application patterns are beads, circles, full surfaces, and edge filling, for instance. So complex geometries require, in this case, again, an individual nozzle design. So next slide, please. So comparison to the sealant applications, we have here glass microspheres, not polymeric microspheres, and this is a huge difference because the glass microspheres are pressure sensitive and can be destroyed by a high shear stress. Again, here our technology is a perfect match because we have a low pressure system and a low shear system, I would say. So we don't put much shear stress on the material itself. So this fact requires an extremely gently handling, as they otherwise would be destroyed, which would result in an increase in density. Okay, next slide, please. So the Viscotex solution, I would like to present you an automated system. So on the next slide, please. Okay, so currently the process is mainly done by hand. The workers take the material out of the container by hand and press it into the cores with a spatula, for instance. So this process is not very reliable, take a lot of time, and you have significant material waste. And what about the health and the safety of the operators, since they are in direct contact with the materials the whole day? So with our dispensing system, you can illustrate this process completely automatic, and with different nozzles, we achieve different dispensing geometries. And you can imagine this is a huge time-saving process and also a cost-saving process since we're now able to use bulk packs. But let's get a quick look on the dispensing process on the next slide. So this is a typical honeycomb potting process on the sandwich structure. So can you please start the video to give you a better impression? So this is the dispensing process itself. So as you can see with the individual nozzle design, we achieve a different or individual bead dimension, and the cores are fully filled, which we can see on the next slide. So there we have the next slide, please. There we have a view on the inside of the cores and also on the bottom side of the cores. As you can see on the bottom side, it's fully filled, and which is a huge advantage. If you look on the inside of the cores, there's no air entrapped at all. So porosity is a huge issue when it comes to honeycomb potting, but with this automated dispensing process, there are no air entrapments at all. So this is, I would say also a huge step in automated production in the aircraft industry. So at this point, I would like to say thank you for the attention, and I would like to hand back the words to Wolfgang to give you, as mentioned before, a brief introduction on the topic of the next webinar session.
Okay, thank you very much, Johannes, for your presentation. Next slide, please. Okay, as mentioned, we nearly finished our presentation, and so we just want to give you an introduction of the next topic for the next seminar, which is probably held in November this year. So we want to introduce the world of micro dispensing, especially with our Preflow brand. Next slide, please. So in general, Viscotec has two brands which are established. So it's the Viscotec brand itself, as you can see on the left, and on the right you can see our brand Preflow with a product portfolio here at the bottom, also for 1 and 2 component dispensing. And this products is especially used for micro dispensing, very small dosing volumes and quantities, especially for application in electronics industry. So next slide, please. With this trailer or video, we will show you what is possible and what will be the main topic for next seminar. Here's again the range for the products, so 1 and 2 component dispenser, Also, static dynamic mixing unit is available, spraying, control units, of course, and also consumables for micro dispensing, spare parts as well, of course. Typically, these products for micro dispensing will be mounted on small robots or access system, very easy to integrate and install, and also, doing very complex application like line and dot dispensing for different type of applications. So I mentioned already, also for automotive and electronics application in general. Here again, it's our static dynamic mixing head and the two-component mixing using the same endless piston technology from Viscotec. The rotors, the screws, are very small, as you can see here, and everything is produced in-house at Viscotec Germany with the status with the rubber parts as well. So quality inspection and providing the highest quality levels, as mentioned, is very important, and we have really very good inspection systems to provide and guarantee the quality of our rotors and stators in general, to have this repeatable and precise dispensing unit. Here you can see the packaging of our micro dispenser, which will be sent, checked, and then sent to our customers. Okay, R&D work is very important, and as mentioned, we customize and look at each application and provide the best solution for the special requirement and application. Also, technical support by training or supporting our customers is a very important topic for us. With our global network of subsidiaries and agents, we provide local support, and really we are not far away from your office or factory. Okay, so with this small outlook for the next seminary, we would like to end our presentation, and we are looking forward to your questions. Thank you.
Right, thank you. Thank you, Johannes and Wolfgang. I think excellent presentation on the dispensing systems and the various applications you covered. I think that was really very interesting, and in fact we have also quite a few questions that have come in. Maybe I'll start with the first question. What is the least distance between the nozzle and the substrate to be sprayed? And can two types of material be sprayed simultaneously with the help of two different nozzles?
In general, it's very not so easy question, because of course it's depending on the material which should be sprayed. But this is the reason why we also try to do some tests in advance, really to define the minimum gap what can be reached. So normally we try to do some tests to define this distance.
Okay, so you have to do some tests before you can define what should be the distance.
Exactly, to get the best spray pattern.
Right. Then the next one, Wolfgang, is also very interesting. Are you using predictive technologies based on process data like viscosity, pressure, dimension, positions to predict the failure rate?
In this case, we are mainly using pressure sensors to control the whole process of dispensing. So by this pressure sensor at the inlet of the dispenser, we have really a good control if we have some dispensing done, we have enough material which is applied, and also to recognize if there are some mistakes. So if something is blocked in the system, so we have a big drop or increase of pressure, and this is what we use to control our process.
Okay. Then is there any method to check the bead miss, like vision system and bead repair could be done? Is it possible?
So far, we are not supplying or developing this measuring devices, but we have a lot of partners or integrators, automation houses, who are using this technologies really to measure the beads, and then to corrugate or make this good shape.
And what is the pressure while dispensing? Is that a standard thing, or it would vary from different applications?
Yeah, this would vary really depending on the material and also on the process parameters. But in general, as mentioned, our systems are low pressure systems. So we try to keep also the dosing pressure as well as the inlet pressure as really at the minimum stage to provide low pressure. Yeah, but it's depending on the process. That's
it definitely depends on the material as well, as Wolfgang said. So if it's a two-component material which is very high viscous, of course there's a high counter pressure then cost in the static mixer, for instance. But we can react different mixer types, different diameters, different flow rates on this behavior. So typically we keep the pressure as low as possible.
Is it possible to maintain less than 0.5 mm thermal gap filler material thickness uniformity across a cooling plate?
But how much was it? 0.5?
0.5
ml? 0.5, yeah.
0.5 millimeter.
Millimeter. Okay, yeah, that's possible, yeah.
Okay. So that's possible to maintain that.
Of course, it depends on the final flow rate which we want to achieve, but with different dispensing needles at the end, we can control the diameter and also with the dispensing flow rate, I would say. So 0.5 mm is okay.
Then there are several questions actually which are related to grease dispensing. So they have asked the best solution for grease dispensing.
Yeah, I have to say we have really a lot of projects for grease dispensing, and so it's a typical layout. I would say a standard layout with our one component dispenser with a typical pail or barrel emptying systems like 25 kg barrels, pails, or 200-liter barrels. We have a hose connection typically to the dispenser, and then we apply the grease on the parts.
Oh, okay. Then the question is, how do you maintain homogeneity of the solution?
Sorry, we maintain the.
How do you maintain the homogeneity of the solution? Uniformity of the solution.
Yeah. So the mixing quality, I guess. Yeah.
Yeah, that's right. The mixing.
So depending on the material, so depending on the mixing ratio, we choose different static mixers, and we control the mixing quality on the one hand side visually. So if there's a uniform color achieved, for instance, so if it's two different colors, and also we measure the shore hardness of the material, because each material supplier gives us the indication which final shore hardness should be reached after a certain time, and once it is mixed, we measure the shore hardness to guarantee the homogeneity or the uniform mixed material.
Then there is, what is the difference between honeycomb dispensing and normal epoxy dispensing? And what changes material, nozzle, viscosity, pressure, or flow rate? So difference between honeycomb dispensing and normal epoxy dispensing.
So I would say honeycomb potting is a special epoxy resin dispensing process. So it's a specific application. So in general, of course, you can say also epoxy resin dispensing, because this is a material which is quite often used, the material type. So epoxy resin is a typical process for us. Honeycomb potting, that's the difference, because we need to fill the honeycombs. So epoxy resin dispensing, for instance, just a single bead or dot dispensing.
Then somebody has asked Johannes, in videos, the seen material container is connected directly to the pump inlet. Then how the material viscosity and processing means heating and stirring is done?
So steering is only possible with a suitable or a preparation system. So if we connect the emptying system, for instance, a cartridge directly to the dispensing pump, we can't steer the material. So this is only possible with a preparation system. And what was the second part of the question?
Heating. The second part was meaning heating and stirring is done.
Heating, yeah, heating is possible only at the dispenser, for instance, at the inlet of the dispenser and at the mixing tube, for instance, and also for the cartridges. But usually this is also possible for all kind of hoses and preparation systems. It depends really on the final temperature which should be reached and on the material properties itself.
So in general, only the cartridges are directly mounted as a material container. Yep.
Yeah.
Then, being a moving part, what is the life of your rotor stator for SC1200? For SC1200, what are the typical consumables and their typical cost?
Yeah, this is a very specific material. I know this material, and this is the most typical question we get. The lifetime of rotor stator. In general, it's also a tricky question because it's depending on parameters we do not know in advance. So of course, what is really, for example, how many shift or how many time the system is running with which speed. So it's very, very difficult to give you a number for the lifetime in this case. And it's depending, of course, on the material itself.
Okay, so it's difficult to give a direct. How are you manufacturing such small rotors?
I would say that's our big secret, isn't it? Because that's our main knowledge we have. So rotor production and stator production, which is our heart of our technology, and of course this is our secret, I would say. We need to keep by ourselves for sure.
Then there is, can you dispense powders with these heads? And can be integrated with other special purpose machines?
In general, it's not possible to dispense of those powders only. As mentioned, we can really handle nearly solid liquids or very high viscosity liquids, but not powders, because they would really destroy the rotor stator because it's getting hot and dry. So that part would be destroyed.
Right. We are in diamond cutting and polishing unit. We need to stick the diamond with steel, and we need to remove the stone once the process is completed. Same time, the paste should be removed from diamond after processing. So I think he's asking whether such an application can be fulfilled by Viscotec. I think it's a little complex, so not so clear.
And I think it's really depending on the adhesives used, more on the material side, I would say.
Yeah, so diamond paste is quite a general expression, which is difficult to assume what's actually behind. Yeah.
Then another interesting question is this device applicable for paint supply in robotic paint shop instead of geared pump? Is the pressure adjustable, or is it just for glue only? So is it for paint also? Can you use it?
Wolfgang, would you say? Yeah.
Yeah. In general, we also have some partners or integrators that integrates also our pumps for paint shops. So of course it can be done. As mentioned, it's a liquid, and we also have application with paints. So instead of gear pumps, also the Viscotec pumps could be used. Yes.
Running cost between piston pump versus rotary dispenser, which is lesser?
So yeah, running costs, if we're only talking about running costs, that's a difference. So one-time investment costs together can't be really compared, since it is a different technology. And I would say the endless piston principle and the progressive cavity pump are definitely the pumps with the highest quality. Of course, this can be sometimes more cost intensive, but for running costs, there can be, of course, a huge saving of money because of long service lifetimes. So we need to divide between one-time investment costs and running costs. So it's definitely worth to consider more in detail with, of course, the application and the process itself.
Right. So this is from the food processing industry. How do you address dispensing challenges of viscous fluid vis-a-vis cooking oil without using compressed air?
So it's more or less yes, the same principle. So we process the liquid just by feeding it from a tank or container, and by using the suction capability of the endless piston pump of the screw pump. But it's more or less the same as using adhesive. Yeah.
Okay. So perhaps the last question for today we'll take is this. Want to have a detailed explanation on how the flow rate of the fluid is controlled with respect to the dispensing height.
Okay. I think it's not really depending on the height of the dispenser, because we need to have a certain inlet pressure into the pump. Once we have the inlet pressure, we are totally independent of the pressure. So we have the electromotor which is rotating, and by controlling the speed of the electromotor, we have the proportional output of the pump. So this is normally how we define or adjust the speed and the flow rate. But it's very, very easy to handle or to adjust.
Yeah, and between the rotor and the stator, there are volumetric chambers with an exactly defined volume. And as Wolfgang said, with a correlation of the drive unit and the pump, we know exactly what flow rate we're gonna achieve in the end, and which is dispensed in.
And then many people have asked also for a copy of the presentation. So if that can be shared, you could send it to us, and then we can send it to the participants.
Yes, as soon as possible, of course. Yeah.
Yeah, sure.
Right.
Hey,
maybe one last
can you hear
question. Please put your question in the question and Q&A box. We are not allowing any direct questions.
Hold. Yeah, already I have
Need
put
to
that
measure
question.
dispensed quality of thermal gap filler battery can be captured. Do we have a volumetric, gravimetric counters for SC1200?
So that was at the beginning of the question. It was very noisy. Wolfgang, did you get everything?
No, unfortunately, no.
Need to measure dispensed quality of thermal gap filler. Quantity, sorry. Need to measure quantity of thermal gap filler. Can be captured? Do we have volumetric or gravimetric counters for SC1200?
So
did you get everything? Sorry, that was.
I think in general, this checking of or measuring, this is also up to the integrator. So we have no special weight scales which are developed by us or optical inspection systems. This is really systems which are integrated very often, but really done by the integrator itself. Of course, we have our output signals of what our motor is dispensing, so we can give this signal, but this is an interchange together with the integrator.
Yeah, this is also controlled in our or monitored in our control unit. They will find the dispensed material quantity. So they have to give you an idea what is actually on the part in the end. And as Wolfgang said, together with a scale, or for instance, we can measure it as well, as we do it also for calibration processes in advance of the each shift, for instance, before each dispensing process.
And one more has just come in. Which type of sensors are used for dispensing accurate quantity?
I would say, as mentioned, typically we use the pressure sensors. And when we use feeding or treatment systems, we're using different type of sensors. For example, for our degassing unit, we're using laser sensors for the level control, but also conductive level sensors or capacitive. So these are different type of sensors, also depending on the material.
Yeah, I think with that now we would like to conclude. It was very interesting. Thank you, Johannes, Wolfgang, for the excellent presentation, and thank you, in fact, to all our participants. We had a very good number of participants who joined, and as you could see from the number of questions also, very relevant questions. People from the industry have participated. Also, our apologies if any questions we have not been able to take. Please, you are always free. You could send it to us, or we will share the presentation, and you could write to Viscotec directly also afterwards if you have any specific questions. And so thank you everyone for your participation. Thank you again to Viscotec for partnering with us for this web seminar, and wishing you all the very best in your endeavors and in your applications in various industries. And looking forward perhaps to our next event together in the near future. Thank you. Stay well, stay safe, everyone. Thank you.
Yeah.
Thank you very much also from our side. Thank you.
Thank you also from my end. Thank you very much. I think it was a great meeting, and if you need anything else from our end, you can contact either us or the colleagues from Viscotec India. We all gladly answer your questions if there is further, obviously clarification needed.
I think if there are some very special application, friends, you could write directly to Viscotec. Once you get the presentation, you will also have the contact details, so you can put it up directly to the colleagues from Viscotec. Thank you. Goodbye.
Thank you.
Thank you.
Bye-bye.
Bye-bye.